Hello, welcome back to BLENDERSUSHI live noding. Remember the other day in the previous live noding I was talking of a way you can turn like a 3D objects mesh point positions into like an image pixel using Sverchok. And yeah, apparently one of Sverchok developer Zeffii have a look, and then he made kind of an enhanced version of the how you can convert from XYZ positions into RGBA, and then he also made RGBA converting back into XYZ, so you don't need to use Blender displace modifier in order to do that, and the result is much cleaner, and then it's actually a lot better. So this is actually how you can turn the RGBA back into XYZ positions. So this is the original, of course. You know, this is just a twisted torus mesh, and then I use the Zeffii version of the XYZ position into RGBA, which is I can just load it a bit later. I'll show you a quick demo, but this one is the opposite. It looks at this image, which is a representation of this spiral twisted torus, and then if I load it and then display the result, it looks like the point cloud. This is the point cloud of the spiral torus. If I actually use the objects in and just grab that torus and then plug in the edges or the polygon, I get the original mesh back. So this is really interesting, right? So because we can actually open another image, let's say I think the one that's from Utah Teapot. Okay, this is actually Utah Teapot, the famous Utah Teapot, also used in the Pixar logo. If we just load it and refresh, what we're gonna get hopefully is the Utah Teapot. Okay, but it's using the polygon from the spiral torus, which is wrong. But anyhow, if we cut this, we get the point cloud of the Utah Teapot. Right? This is I found this really interesting. What's more interesting is how Zeffii kind of utilized Sverchok to make this node setup, and let's break it down. I just have a study of this a little bit earlier. So basically, you can learn quite something from this setup, basically. Okay, so let's have a look. This image, right, the one with the pixels, it's let's see how many pixels this one. This one is 35 by 35 pixel dimensions. It's rather small, but this represents all the positions of the points for the Utah Teapot with some extra stuff over here that we can get rid later. So let's have a look at the process one by one. This is Sverchok object ID node. This one will grab all the images if you have multiple images. Currently we have Utah and spiral. We can filter it. Just select one with the Utah. So we are already just using this image, and then grab every single pixel from this image, and from this pixel, like imagine like a table of data here. From this pixel, just we want to mask out the alpha, because this object represents the RGBA, red, green, blue, and the alpha. We don't need the alpha for the object's vertices. We just need the RGBA information. So this big quite something that looks quite complex is actually just creating true and false kind of masking data. So if we use the stethoscope and then have a look at the data, it's just a bunch of 111, 01, etc. It's like a true or false. Let me save this real quick. This is RGBA to XYZ explanation. So if we start from the beginning, it's basically, okay, get the total number of this pixel, which is going to be 4 times RGBA, kind of a list of value. So we have number 4 here. Divide the total by 4, and based on that, create a repeating list of 1110. 0 will be the alpha. Then we want to get rid of the alpha. That's why we have 1110. It's like true, 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 and false. So if we have a look here, that's kind of the repetition of data that we're gonna use to mask out the alpha. And using list repeater, delete level, list join. This is very Sverchok thing, very interesting, a little bit hard to understand, but once you get it, it's like really powerful. So once you get this pattern of data, we just plug it back to this list masking, so we can mask out the alpha. So we have just RGB. We have this RGB, RGB, RGB. So we can now, what happened next is kind of splitting the RGB into 3 values, and then these 2 is kind of normalizing the data, so the objects kind of sit in the center within the bounding box, I think. But cut the story short, from the list split here, RGB, look at the data here, RGB, we can just use it as the vector of position of our Utah teapot. That's why we have the points back. Yeah, interesting, very, very interesting. And this is a kind of a perfect conversion from mesh into a 2D colorful pixel image that's kind of random, and back into the point position. This image only contains the XYZ positions of the Utah teapot. It doesn't have edges indices or polygon indices, so that's why we can't really have the Utah teapot back unless we, if we try, it's maybe not perfect, but if you kind of want to see, you can use KD3 closest edges probably. Okay, this might take a while. This is not a true representation of the Utah teapot, of course. It's just connecting points that's closest. You kind of get it. You can try using like meta balls just to get the shape, but that's not quite the point anyway. This is kind of a fun thing that I did. I guess it can be useful at some point if you have like a sequence of this image representing vertex animations. You can reuse the sequence of image back and then animate the points while keeping the same indices. So it's something you can use for game engine, and there, I think with some kind of a little bit of programming, you can source image sequence and then pipe it into kind of like real-time deformer of a mesh. It's a little bit complex. Maybe you can do that using Unity or Unreal Engine, but shouldn't be too hard. It's actually, so normally the game engine likes I think join animations or transformation animations. It doesn't really like vertex animations, but using this method you might be able to animate a vertex to use vertex animation in the game engine. It's a interesting little hack. Okay, by the way, this you might notice that we have an extra points here. You can actually get rid of it simply by using the list slice here. So just get rid part that you don't want, that we don't need. Let's see. So yeah, up to maybe up to 1293 and then start from 0. So we have the proper Utah teapot. 1292. This is actually from this guy right here, because we have the original Utah teapot. Where is it? Extras, teapot, this guy, objects in, get selection, polygon. So we have the teapot back. Maybe it has slight differences. So yeah, that's anyway, that's pretty interesting. So we have now a way to convert our kind of like cryptic image back into point cloud. That's the main point here. Don't worry about polygon indices. You might maybe the polygon indices can be like a secret code that you can give. You can play around with your friend, for example. I have suddenly have an idea. Maybe maybe you want to create like a secret message, and then you want to give it to your friend as an image like this, and tell them how to get it back as a 3D objects. Maybe. Anyway, that's pretty much for this live noding. I guess I'll see you in the next video. But if you have any comments or feedbacks, you can leave it down below.